This is step number 5 of the final project of this course. And now that we have the Arduino code finished and tested, let's write the code on the Raspberry Pi with Python. So the step 5 is gonna be with Python. Now we are going to use the Raspberry Pi functionalities and also the application logic to define what the application will do, and of course to interact with the Arduino so we can translate this application logic into real physical actions. And we're going to use a slightly different method for the steps here. So for the Arduino, we just initialized the component and then did the input commands and the output commands. On the Raspberry Pi, we are going to follow the logical order of the user journey. So the user is basically who is using the application. Okay, because here as we are writing the application logic, well, this is gonna be a better way so we can iterate every time on the next step. So we can validate one step and then iterate on the next one. And so first of all, well, in this step, we're gonna initialize serial communication. We're gonna send a message on the LCD to give the information that you have to press on the push button. And we're gonna read from the push button. So at the end of this step, we will be able to know when we have pressed on the push button from the Raspberry Pi. And then in the following steps, we are going to take a photo when the button is pressed. We are going to send that photo and a message to the Telegram chat with the Telegram bot. And then we will write the code to open the door, and we will write the code to deny the access. And so those are gonna be step 5 to step 9. All right, and let's get started. So here I'm going full screen with TonyPython IDE, and I keep that on the side to check the Arduino code and change something if eventually we need to change something, but I think that should be good. All right, so let's write the very beginning. So the interpreter. Okay, and then we are going to import serial library. And also let's import time directly because we are going to need to use it. So the first thing we do is to init serial communication with, so let's say ser is equal to serial.serial. Then the port, let's actually find the device name, ls/dev/tty, and all the options. We have that one, that should be the Arduino. So /dev/tty ACM0. The baud rate is the same right there, 115,200. And then let's put a timeout, a read timeout of 1 second. And so for this project, we're not just gonna connect to serial like this, we're gonna put that inside a try, except, so except serial.serial exception in case that we can't connect, and we're gonna retry. And so to retry, I'm gonna put a while here, while true, but that's inside the while true. So if it works, we do print successfully connected to serial, and we break out of the while. If it doesn't work, we do print could not connect to serial, retrying in 1 second, 2 seconds, whatever. And then of course time.sleep with 1 here. And let's add another log here, actually print, to make it more complete, trying to connect to serial. Okay, so we have first trying to connect to serial and then successfully connected or could not connect, retrying. After we are, so when we reach line 16 here, let's just put the wait, so wait after setup, and let's just put print waiting for 3 seconds. Okay, so we know we have to wait. So time dot sleep. We give some time for the Arduino to be ready, especially now that we also have, as you can see in the setup, we have a delay 1 second, okay? So the time that the serial is initialized and plus this 1 second, we're just gonna wait for 3 seconds on the Raspberry Pi, so we know that after those 3 seconds, everything is okay. And I'm gonna do ser.reset input buffer. So anything that was received from the Arduino before those 3 seconds is gonna be discarded. And then let's say print, okay. What we can do also, well, just after we have initialized the serial and waited for 3 seconds, is to send actually 2 commands to the Arduino. Because when we start the application, if you remember, we have something on the screen that says push on the button to call, and we also have the LED which is blue. Okay, so blue is basically the waiting state. And so before we write any while loop here, we're gonna add some comments. So ser.write, we're gonna do print text push on button to call with \n, of course, dot encode UTF-8. It's better with quotes like this, and ser.write. So we just send the 2 commands one after the other. Okay, so the first command is gonna be, so with the read string here, read string until \n, is gonna read this until \n, so it's gonna get that. And then the other command is gonna be in the buffer of the Arduino, and it's gonna be read just after it. And because we go very fast in the void loop, it's just like we are going to execute the 2 commands at the same time. Let's do set LED and let's put 000, and then so red, green, blue with \n and encode UTF-8. All right, and as you can see, well, we're gonna send a few comments to the Arduino from the Raspberry Pi, and every time we need to do that ser.write. So we have the comment, but we need also to add the \n and do encode. So what I'm going to do is I'm going to create a function here, just a function after we initialize serial, def send to Arduino with the text we want to send to Arduino. Okay, so then instead of just doing ser.write, we just do send to Arduino with the command directly. We don't need to worry about the \n, about the encoding, etc. And so we're gonna construct a string. So string to send is equal to text plus \n. Actually, I'm gonna do text.rstrip. Just in case we send something with some \n character, some carriage return, we're gonna remove them to be sure there is none, and then we're gonna add one, so we only have one \n at the end. And then ser.write string to send.encode UTF-8. All right. And so we're gonna save a bit of code and make less mistakes when we need to send something to the Arduino. And so I'm gonna do send to Arduino with just this. Okay, and then send to Arduino with set LED until there. Okay, and I can remove that, and the code is now a bit cleaner. And well, one iteration you could also add is add other functions on top of that. For example, print text on Arduino, set LED. And so you're gonna construct the string directly, for example, print text on a function, and you just need to send this text, or you just need to send the colors. And so you can have one function for each command you send, but I'm gonna keep things simple here and just send the entire command, but without having to worry about this \n at the end and the encoding. So now everything is okay. We have put some text on the screen and set the LED. what we're gonna do is the while loop. So all of that is kind of the void setup, okay, of the Raspberry Pi, and then the void loop is gonna be the next block of code. And so let's put run main loop. Maybe let's put OK, and then main loop is starting. So we do a while true. Let's put directly time.sleep for 0.01 second. So we're gonna run this loop at 100 Hertz. And let's put directly this inside. So I'm gonna put more spaces here. Inside a try except structure except keyboard interrupt. And what do we do here? We do ser.close with a message print closing serial communication. And then let's say print end of program here. And maybe we can also add before. I'm gonna add dash. So basically every log that we're gonna print, then we have dash, which makes a clear separation for the end. It's just for us, the developer, to get nicer logs when we run the application, okay? So we have this, serial is correctly handled, and now let's do if ser.in waiting, because let's not forget what we want is to receive the button pressed command. So if we have something in the serial, we do message is equal to ser.readline.decode utf8.rstrip. So here you could also create a function like receive line from Arduino or something like that. But as we are only going to get one command, well, I'm just gonna leave that code here. But if you were to use this pretty often, then creating a function would be a good idea. And let's do if message is equal to button pressed. Let's check that we have button pressed, that's the same. In that case, let's do print open door request, because that's what this means. And then what we're gonna do is we're gonna take a photo with the camera, send it to Telegram, but that's for the next step. What we could already do is to send to Arduino the command to print some text. So print text. So basically to give the user the information, the feedback that, well, the request has been received, okay? If you press on the button and nothing happens, well, you can't know if it worked. So if you press on the button and you see a text like please wait a few seconds, then you know that the request has been sent. So we're gonna change the text, again the LCD, please wait for a few seconds. Okay, and then we are gonna handle the request, and when we decide to open the door or to deny the access, we're gonna also change the text. But that's for a future step. For now, we just acknowledge that we have received the request. And I'm gonna add also an else here, because as we did for the Arduino, so on the Arduino we read a string, and if the string doesn't correspond to anything that we expect, we clear the input buffer. We're gonna do the same here. If we receive something that is not button pressed, then we're gonna do ser.reset input buffer, so we just clear everything else, and so we give another chance to read correct data when we enter the while loop again. Okay, now let's save this program as intercom, let's say step, and we are in step number 5. Okay, so the Python program will actually start at step 5, okay? The Arduino is gonna be step 2, 3, and 4. And for the Python program, we will have step 5, 6, 7, 8, and 9. And let's save this. So the program here the Arduino program is still uploaded and running on the Raspberry Pi. Now we can run this. So let's run the code on the Raspberry Pi. Successfully connected. You can see starting here. Okay, main loop is starting, and you can see push on button to call. The LED is blue. I push on the button. You can see open door request. We have received a log here, and please wait for a few seconds. So we have correctly received the information that someone is ringing the bell. And that's the end of this step number 5.